Hello, this is a demonstration on using a B&K Model 600 tube tester and how to calibrate it once it's been restored or refurbished. One of the main reasons for buying this tube tester is the grid emissions test here. Not many other tube testers have them. The only other ones I know of is the Senko units and also Seiko. They do a similar model. Basically, once you've changed all the resistors, any out of spec components in there, you can go ahead and do the grid emissions calibration and also the shorts calibration. For that, it's all in the service instructions. It tells you exactly how to do it using just a 20 megohm resistor and a 1 megohm resistor. I've built this unit here just to house it. Makes it a bit safer because when you're doing the shorts calibration, you have to get in there at the same time with it when the unit's powered on. So that just makes it safer, but you can use just one 20 megohm resistor and one 1 megohm. Both of them are inside here and it's a lot safer. First of all, we do like a grid emissions test quality calibration. So to do that, this one goes in socket 8, and all we have to do is press a grid emissions test, and according to the service instructions, adjust the meter to this reading 20. And we've got a potentiometer here, the top here. We can just turn that to adjust the reading. And as you can see there, it's reading about over 30 from where I'm standing, 35. So we just turn that down on that potentiometer and get it onto the 20 there. So that's it, simple as that. Set the needle so it's reading 20 and you've set the grid emissions test up. You can actually increase it if you want that set at 20. So if you want to set it to detect leaks over 100 megohms, you can do so. It's all in the service instructions here. For the shorts test, this one here, it'll tell you in the service instructions, has to go down to 1. And then all we're going to do, 6 and 1. You can't see it here, but you have to adjust it from inside. There's a light just slightly on, you can't see it, but it's on. It's just basically flickering. I'm just going to open this up now. I'll switch it off first. And we'll just open it up to see the inside. And the one that you use for the shorts calibration is this potentiometer here. You'll just vary that potentiometer until the light just comes on. It just wants to be just past flickering, a steady glow, but very light. Inside here is the components that have changed. There's about 5 resistors and there's 2 electrolytic capacitors that should always be changed. That's this one here, and there's one down here as well. I don't know if you can see it. All of the resistors are all, apart from one, are all carbon composite resistors, so they need to be changed. There's one large one. It's a 5-watt wire wound one, and because it's wire wound, they very rarely lose their tolerance. So if you check it 99 times out of 100, it's going to be in spec and it's okay. There's a couple of microcapacitors, they're the same. They've got a wide tolerance, those 10 or 20%. So they very rarely go out of tolerance, so no need to change them. But the carbon composite resistors, there's a total of 5 of them. They all should be replaced. This is the vacuum tube that's used for the grid emissions test only. It doesn't do anything else. It's just for the grid emissions test. And as I say, for that shorts test, you would just adjust the potentiometer that was behind near the meter there until the light just came on. I can just switch it back on now. So that's basically the calibrating of the grid emissions and the shorts test. Now we're just going to check a valve now. And we'll just check a 6AQ8 valve. And I know this had some grid leakage. And to do that, for the 6AQ8 valve, it's also known as the ECC85 valve. The heater has to be on 6. A has to be on 32. B has to be on 6. And C is on 2. So we can put this in now. It tells you which socket to put it in as well in the data book, and it's socket 2. So that's socket 2. And it immediately does like a check for shorts straight away on the major shorts. And for checking the rest of the elements, you just rotate this valve. It's just a little flicker there, round and round. If there's a steady glow, a full glow, you wouldn't test the valve, as it's just like flickering there. So just flickering there as well. So this is okay to do a grid emissions test, and it should show faulty. And that's actually showing faulty because once again, the grid emissions using this top scale, it's white and it's green there at the top. It's gone well past the green, so this one is a grid emission failure. I've got another valve, which I know to be good. So I'll just try that. And once again, we can do the test, shorts test, but I know it to be good. So we can do the grid emissions test on this one now. And as you can see, it hasn't budged at all. It's a perfectly good valve. So now we can go ahead and do the quality test, the emissions test. And once again, we're using the bottom scale now, and it's well and truly into green. It's reading about 82, 83 from where I'm standing. Now this is a dual triode valve, so there's actually two tests to do on it. And for the second triode, A stays in 32, B stays on 6, and we just rotate C to the number 7 position. So once again, we can do a grid emission test on that one. And as you can see, the needle hasn't moved, and we can do a quality test now as well. And once again, that's reading about 75 from where I'm standing. So that's an excellent test on this valve. Thanks for watching. Bye bye.